Welcome back. In this video, we'll be examining physical changes of matter. Here is a piece of dry ice, which is the solid form of carbon dioxide. You probably already know that carbon dioxide is one of the gases in our atmosphere. And it's one of the gases you exhale with every breath. So it's not surprising then that, at room temperature, the dry ice does indeed change directly from the solid form into the gaseous form. Dry ice is very cold, which is why it's being held with a pair of tongs. And in order to keep the dry ice solid, we'd have to store it at a temperature colder than minus 78 degrees Celsius, which is minus 109 degrees Fahrenheit. Observing this piece of dry ice, we can see something around it that looks like mist. That's not the carbon dioxide gas that we can see. It is the water vapor that was in the air condensing into a fog. The fog we can see is little tiny droplets of water that are condensing from the humidity in the air. As the quickly moving water loses energy and slows down near the cold dry ice. The little droplets are going downward, of course, because they are denser than the surrounding air. Now let's add a small piece of dry ice to a flask that has a balloon attached to its open sidearm, and we'll put a stopper on nice and tight. Take a few seconds to watch this system. What do you observe happening? Many of you wrote that you observed the balloon inflating, and the only way that can happen is if the solid carbon dioxide is producing a gas to blow up the balloon. Let's look at a second similar flask, but this time there is water already in the flask, liquid water. Do you see it there? Let's see if there is a difference in what happens when we add a small piece of dry ice this time. Please take a few seconds to look at this system and let me know what you are observing. Do you see any differences with what you observed last time? Did you observe the fog that was forming in the flask from the presence of the small water droplets? Again, that's from the cold temperature of the carbon dioxide dry ice, causing the water vapor to condense into a liquid. Another thing you might have noticed was the bubbles of gas coming off of the dry ice. Even though we can't see the carbon dioxide gas in the air around us, we know that gas is being generated from the dry ice as it warms because we can observe those bubbles forming. A final thing you might have noticed is that the balloon is inflating much more quickly this time. The dry ice is so cold that, on the outside of the flask, some frost has formed as the water vapor in the air has condensed into cold gas and then frozen.